Thanks so much for having me. So, the title of my talk is quite big, so I'll try and uphold to it. So, the plan for the next 20 minutes that I have for you is to give you a quick briefing as to why I'm here. I'll tell you about why I think this time is different for building artificial intelligence companies. I'll run through very quickly some compelling use cases that we see for products and services that are powered by AI. I'll talk more deeply about some of the challenges that we see for operators building companies and that we as investors tend to consider quite closely when evaluating businesses. I'll run through a case that I think is important for human-machine collaboration, mutual learning, and context awareness, and how this can improve the systems that we build. And then I'll tell you where we're at in the financing and exit market, which I think is again, an important backdrop to have a discussion like this. So to kick things off, as Lenny mentioned, I'm an investor at a firm called Playfair Capital. We're an investor in Ravelin, amongst other artificial intelligence companies. We focus on the early stage, and we want to invest in businesses that are trying to reimagine the way that we live and we work. We invest in businesses across the world, but most of what we do is in Europe, and more specifically in the UK, in businesses where data, core technologies, and user experiences are differentiators. And actually 20% of our life portfolio is in technologies within the AI landscape, and some of them are listed here below. So the animations aren't live, so I apologize for that. So that's going to be really hard to digest. But as a context for discussion as to why I think now is different, I wanted to walk you through the various cycles of booms and busts that we've seen in the AI space ever since the inception of it on a research angle in the 1950s, which is when Turing published his seminal work on thinking machines, and the first Dartmouth conference on artificial intelligence was started in 1956. There was a huge amount of government funding in the space that fueled early work in neural networks and in language. But following this, after about 20 years, it was reported in the UK and in the US that a lot of the research goals that were attempted to be achieved fell significantly short. And this was pioneered by the Lighthill report and DARPA. And what happened after that was the first winter, where significant government funding cuts happened, largely an explanation of the fact that there was limited compute capacity and limited data to build intelligent systems. But then we saw another boom, and this one was driven by expert systems, where developers were encoding knowledge that was embedded within professionals in knowledge working spaces and encoding rules-based systems to execute what they were doing manually, but at scale using machines. There's a huge amount of government money, again, pouring into the space, but predictably, 15 years later, again, these results were not as promised. The systems were incredibly brittle because they were rules-based and they weren't scalable. On top of that, the new DARPA leadership was relatively anti-AI, so again, cut funding in the US. But now I think we're really in a new boom. And over the past 20 or so years, we've seen specific systems beat champion chess players. We've seen Watson win at Jeopardy. We've seen Apple launch Siri and voice detection in 2008. And we've seen how speech recognition has gone leaps and bounds since then. We have driverless cars and really powerful image recognition and translations and a whole bunch of other applications enabled by deep learning. So the question really is what really changed since the 90s? And I'm sure a lot of you know this, but I think it's really a watershed moment because we now have 3 billion people online, and that's 40% of the world. That's compared to 14 million in 1993. And there's 2 billion people that have smartphones compared to 0 just 20 years ago. And what's incredibly surprising to me is that users are addicted to these devices. There was a survey in the US that looked at millennials, and it found that 87% of them never have their smartphone away from them, either day or night. And it was something like 80% of them check their phone as the first thing when they woke up, and I know I do this. So really what you're doing is you're creating a huge trail of data assets about your behavior, what you like to do, who you talk to, what you know, and where you go, and that just didn't exist before. And on top of this, we're having infrastructure now that is just orders of magnitude more performant and cheaper than ever was before. And in terms of learning approaches, there's been a lot of research recently in long short-term memory, in deep architectures, transfer learning, and a bunch of other areas that are improving the way that we could build systems. So altogether, this is enabling, I think, 3 different routes to market, and within those, different application areas. So broadly speaking, you've got autonomous agents and robots that either roam the land or fly in our skies or navigate on our seas. And there's a lot of machines in manufacturing that are now producing data that we can use to build automated systems. There's a lot of companies now creating core technologies as a service. You're seeing this erode technology barriers by providing systems for classification, predictions, complex optimizations, APIs for voice and videos and images. And some of these are being used for domain-specific applications, which personally I think are going to be the ones that have the most legs going forward. And those are tackling problems in finance and security, in media, and especially in knowledge work. And I think a big area to be pursued in the future is in medicine. But looking at all of these different areas, I think there are a few areas of challenges that are faced by everyone. And these really fall in terms of operational, financial, and what was the other one? Oh yeah, commercial. And the slide is completely screwed up, which is annoying. But anyway, I'll talk you through it. So really what we see is on the operational front, because AI systems are usually quite brittle, they take a lot of R&D to build, what you find yourself, if you're constructing a company in the space, is there's a really long R&D cycle. And it's hard for you to intrinsically balance whether you pursue a long-term mission or if you focus on more short-term monetization, which oftentimes means that the performance of your system might not be up to par with what you expect in longer term. So really what you need to balance is figure out who your user is and what the use case is, and really engineer a system so that it's performant up to the expectations that you know your audience has. And some of this plays into education of your audience. The other operational challenge that you all know very well is that there's a very shallow talent pool. There's roughly 500,000 members on Kaggle, which doesn't provide you with a lot of individuals who can man your companies. And so it's important for you to build your network and be sure as to the sources through which you can hire talent and how you retain them. And the last area in the operational front that I think is not emphasized enough amongst engineering companies is having talent in the company that focuses on user research and product design, such that when you emerge out of your R&D exercise, you actually have a system that's been architected specifically for the use case, knowing what the user psychology and behavior is of that user persona on the end, which has most often than not implications on the architecture of your system and how you build it. So in terms of commercial, I think the main point I want to communicate here is that we're still in an early age of having buyers that are educated in AI and know how these systems work and know what the benefits are and the trade-offs are and what kind of investment needs to be had in order for returns to be generated. So that can often lead to a longer sales cycle. And so it's incredibly important here to really understand what the bottlenecks are for you to deploy your product in an enterprise if that's your focus area. And a tangential point to this is whether you undertake a repeatable sales cycle with a product that's applicable to a large number of individuals within a specific area, or if you go on bespoke builds or provide consultancy services and support that can drive you forward. On the financing front, I'll get to it a little bit later, but basically the take-home point is there's not that many people that you can talk to in the UK and even broader in Europe. So you need to very carefully consider who you take money from, and importantly, when you do fundraise, you need to have that capital buffer that allows you the breathing room to properly engineer your system and ensure that when you hit bottlenecks that you don't need to go back into the market with a half-baked product that no one can actually experience. Because this is a market where investors like to actually see something deliverable, and they largely don't invest in engineering and data assets, unfortunately. So a key consideration that I think a lot of you are aware of that's actually just happened in the last 6 months is the increasing open sourcing of core technologies that have been built over the last 5 years at any of your favorite companies, whether that's Facebook, Google, or Yahoo, or IBM. And I think the open sourcing of this is sometimes a marketing exercise, sometimes it's it's to improve the recruitment ability of these businesses. But really, I think the follow-on question is how do you operate and how do you build defensibility in an area where what was previously deemed to be a core competency, which is technology and IP, is very quickly eroding. And so the solution that I posit is that you need to build habits amongst your users, and the best way to do this is to involve them in your product. And that's because we all appreciate that machines can't quite recapitulate human cognition, and really involving a user in a flow of a product improves results that are generated by the machine. So here I'll give you two examples of products that I think do this quite well. The two screens on the left is a mobile application published by Babel, which is a machine translation service. And so here, if you're a business or an individual user, you feed it a text in a language, you select what output language you want. The majority of the transcripts are actually generated by machine. But on the back end, after the machine spits out its translation, the text is split into small bits and it's fed out to a community of human translators who can edit the transcripts on their mobile device, explain why the translation was good or not, and point out errors, which are then recorded back by the system, which then tunes the models to improve the machine translation over time. So I think this is a great example for how humans can actually benefit from most of the legwork being done by a machine, and both systems can improve from one another's intrinsic knowledge. On the consumer front, I think my favorite photo application right now is Google Photos, which can ingest your whole photo library in seconds and then automatically start to categorize your photographs by place or by things, or even by people. And what I really like is that if you click on one of the things in the category, so say sky on the bottom, and it'll return results that it thinks include sky, you can select images that aren't sky, and then select to remove them. Which then records the fact that the features that were emphasized to generate this classification are wrong, and it improves the classification over time. So with this, by building habits using a user in your flow, I think you can start to create proprietary data sets, which is another way that you can start to differentiate in a world where technology is no longer a differentiator. So here I'll take an example of a portfolio business called Mapillary, which is a crowdsourced computer vision company that tries to build street view products. So here you have a mobile phone on the top left. It's running the application. Essentially, you take sequential images as you're walking or biking or driving of any path. You upload the images to a database, which is rapidly growing, now including 48 million photographs. And these photographs are then stitched together to generate a 3D reconstruction of that path. And then you can do some pretty interesting work like traffic sign detection, which a number of municipalities pay for. So here, there's an automatic classification system which will detect certain street signs in different geographies. And what they've done is then farm out the data set to a number of users, 100,000 of them, and then ask them to correct any mistakes that have been generated by the machine. And then what you see here on the right is a precision recall curve, which is showing you the difference in precision recall before and after training from the machine-generated classifications and the human curation on top, where you see that the precision is largely increased after the red curve versus the blue curve at different areas of recall. So you have less false positives, and you're classifying street signs better. So here you're creating proprietary data set where the user's in the loop and the performance of the system increases with their involvement. So really what I'd like to discuss is the future of human-computer interaction. Because after reading an interesting FT piece this week on IBM, there's a brilliant quote which I think encapsulates some of the topics we've been discussing tonight, which is, in the business world, a brilliant machine that throws out an answer to a problem but cannot explain it is basically of little use. And Stephen was explaining this today as well, where there's an important trade-off between performance and explainability in a model. So that's what I like to term real-time mutual learning. It might be the wrong term, but there's another quote that encapsulates this as well, which is, dumb reliance on smart technology is a great dead end of human-machine interaction. And so what I think is both humans and machines have different ways of learning, and what's important is that we both understand how each other learn, so over time we can build more performing systems. So a little really simple schematic of how I think the system should be built is that, for example, in the search engine query situation where a user wants to find an image of a bird in their photo library, they'll enter a query, there's a certain computation that happens and returns a result. But instead of just aimlessly returning the result, there's an explanation that's built on top of the computation which tells the user, this is a bird because it was in a tree, and most of the time birds live in trees. And there are some cases where tigers live in trees or lions live in trees, and a user can feed back and say, look, this is not a bird because it clearly has like 4 legs and it's furry. And so I think in this case, having the user there and educating the machine as to how it thinks and vice versa can improve learning systems. And so the last area that I'm quite bullish on in AI is the idea of how contextual intelligence, so our knowledge of the situation and the circumstances in which we make actions, can actually improve downstream predictions in a lot of different domains. And I'll just take two simple examples. So one is sales optimization. So say you're trying to prospect for new leads. You get the new leads in, you're trying to qualify whether you have a high probability of closing them or not. In addition to what kind of business they are and whether you knew them before, there's a huge trail of information that's there with you and that customer. So things about describing what file topics you're communicating with, what location you're in or time of day, what's in your calendar, what previous habits you've undertaken with those leads, and any news about that company, which you can then use to inform whether that lead is most likely to convert or not. And in the health situation, I think that we all carry around known histories of ailments, whether that's largely dictated by genetics, but we're also carrying around really powerful devices now that are gathering lots of data inputs about our everyday lives and our physiology. And increasingly, when some of these trackers are monitoring physiological traits that change every day, I think we have an enormous amount of contextual intelligence to bind with inherited intelligence to detect whether, in fact, we're living healthy lives or whether we're at risk of disease. So to summarize what I think the three-pronged areas are to build a strong AI business, which I think is important given the considerations we've discussed tonight, is really it's about people, products, and data. So on the people front, you need to have individuals who cover researching, designing, engineering, and supporting product, while also investing in longer-term R&D. From a product perspective, you really need to understand your user personas and insights that show that you're solving a recurring and high-value problem. And from the data perspective, you need to ensure that the user is there and that they're leveraged in the process, and that you're creating strong data network effects there as well. So to start to wrap it up, if I were building an AI company today, I would be really mindful as to where I started. To put this in perspective, last year there was $55 billion invested in technology companies in the venture asset class, of which $3 billion or less was in AI. So it's still a small teardrop in the total asset class. When you look at round investments, you see that 2/3 are early stage, so either seed or Series A, and 80% of the rounds are less than $5 million. So that if you factor in the cost of infrastructure, of recruiting, of sales and marketing, that really doesn't get you very far. Probably buys you at best 2 years. And there's only been 300 deals in these businesses, and 90% of those deals and the amount invested occurred in the U.S. There's only 10% that was non-US, and that's mostly Europe, of which the UK dominates. But I was looking at data earlier today to see how many companies, broadly speaking, fall under AI by just essentially querying buzzwords that a lot of companies use in their summaries. And really what you see is that over the past 5 years, there's only 50 businesses that fall under that. And the most highly funded ones are SwiftKey with 24 million, and another NLG company which had 44 million. And you compare that to, there's about 600 businesses in the US with $6.2 billion in funding in that same time period. And And actually on the value creation side, it's still very early on in the cycle. There's only been 36 acquisitions this year. The amount raised before the exit has been $17 million. So that's roughly Series A or Series A plus. And these businesses are very young. It's only 3 years old since their first round of investment. And again, most of the companies that were acquired were American ones. So in closing, really the key points are I genuinely do think that this time is different. I hope that the cycle of booms and busts has proved that. I think that open source, as you all know, is eroding technology barriers, which just has important ramifications for how you think about your user, the use case, personas, and how you deliver value and how it's assessed. I think that right now the venture market has a low tolerance for technical risk. The number of people that you speak to in the industry do not think that another DeepMind acquisition will repeat. Most of the industry optimizes for momentum right now versus long-term innovation. And I think the data proves that you need to have some kind of exposure to the US if you want to create value and give your business the best shot of success. So with that, thanks for your attention and happy to take questions.
Cool, thanks Nathan. Are there any questions in the audience? Not a single question. Okay.
So you said that machines don't yet recapitulate human cognitions. Products must involve the user in the end loop to improve machine-generated results. Wouldn't you mainly say that that's because of where we've gotten attention so far? There's plenty of potential in extending what we can do with machine learning, because right now we finally got the computational power that wasn't there before. And I think, with 3-4 years, we're just scratching the surface. We didn't even have the GPUs with the bandwidth. Yep. But 2015 was a special year for me because that was a year where we saw that we reached 2 gigabit per watt. And that's pretty much the same as a human brain in bandwidth. So thanks to Jensung and his team at NVIDIA for putting that in play. But I think we're just scratching the surface of this.
Yeah, so I mean, I agree with that comment. The compute capacity is definitely up there. But as with these GPUs that require a ridiculous amount of power to run, you can't actually have them running all the time to do real-time sensory detection of, for example, noises around you. And on top of that, I think there's still a lot of work to be done to figure out how the brain actually works and how you can actually encode that in a machine. And I think there's probably some interesting work that machines and algorithmic ways to detect things like emotion can start to teach us about how to better explain how we perceive the environment around us. Because especially when it comes to creative disciplines, it's very hard for us to describe why we think things are beautiful. So I think having very tight integration between human and machines can actually help us both understand the broader goal, which is endow general intelligence.
I have a question. You showed some numbers in terms of how much money is invested. I wonder if you have like a rough estimate. How much do you think is invested in total, including large companies, government, and so on? How much you think will be invested before the boom ends? And how does that compare with previous booms?
Yeah, good question. I actually haven't looked at the government funding that was injected last year. I mean, all I know is that the most brilliant academics are most of them leaving. They have some kind of corporate interest, whether that's in Oxford or Cambridge, or most of them are affiliated with Microsoft Research or Google DeepMind. So if that's any indication of the fact that government really isn't there to support their work, that's sort of the best answer I can give you. But my feeling at a high level is we're sort of going back into innovation being driven by very well capitalized balance sheet companies back to when, for example, AT&T and Bell Labs existed. And so now the place to go if you have brilliant ideas and you want infinite resources and infinite creativity and freedom to do what you want is no longer MIT or Stanford or any of the other universities. It's Google DeepMind, really. It's Facebook AI Research and these other places which have basically investors on their side who say you can go try and fly drones around the world and give internet to people and that's fine. But go try and write a long-term grant in academia and publish papers in the short term that can ensure that you progress up the echelons and get funded in the longer run. I think is a different prospect. So yeah, I think we're back to companies driving a lot of innovation. And I think we see this with a lot of big publications. There's always some kind of corporate affiliation.
Hi. You mentioned proprietary data sets.
The what, sorry?
Proprietary data
Yes.
sets as being the differentiator. Proprietary data sets are generally owned by bigger companies. So that ring fences anybody in AI independently has a problem raising funds because it's all about proprietary data sets and how you train your algorithms. It's like a little bit of a catch-22. So you're back to, you need to join a big company in order to access the data sets. How do you break that catch-22? Mostly people here are independents.
Yeah, so I think that's why crowdsourcing has been particularly popular. I think Mapillary is a good example where all the data that they have in their database is owned by the business, and it's generated by users because users have this emotional desire to map their surroundings. It's one of the most basic activities that humans have done ever since we've been able to travel. And so I think cracking human behavior is a way for you to build a product around that behavior and encourage the creation of data which enriches a user experience. So it's kind of back to first principles. But I definitely agree that larger companies do own significant data sets, and perhaps that's why. That's one consideration for why this time is different, is that the incumbent technologies actually have a leg up over smaller ones. I'm sort of surprised as to how incumbent companies, for example, in the medical services area, especially in imaging, who are sitting on huge amounts of MRI and CT and X-ray data and aren't necessarily armed with a bunch of computer vision researchers, aren't saying, look, we have this data set, here's a call to action for any vision company that can help us analyze this content and streamline, our completely drained medical infrastructure. And so, last year IBM bought, a medical imaging company for $1 billion that had all this content. So then you kind of come back and say, well, the way to approach that is volunteer, or not volunteer, but sell your services to a larger company so that you can access their proprietary data set, inform your models, and then on the basis of that, generate some cash flows which can sustain your R&D. And then in the early days, you're basically a small consulting company. But that's the way that you can get off the ground, because otherwise I agree that it's very tough.
Okay, well, thank you very much, Nate.